So I am going to talk to you and ramble about a whole lot of things, then we're going to cinch it up in the end. And I'm excited to talk about this because it's potentially inflammatory stuff. So we'll see how it goes. So just to give you a little bit of a heads up, I'm Redbeard. I work over at CoreOS. That's how you can stalk me on the internet. I used to have this much bigger thing hanging off my face, and then I got tired of all the Duck Dynasty comments, so I shaved it off. And, as our CEO pointed out, one of the two major epics of CoreOS is that the versioning of the actual images all start on January 1st, 2013, and that I was clean shaven on the first day that I started at CoreOS. So maybe this will turn into like IPO beard or something. But moving on, this is going to talk about history in some weird ways. And I specifically point this out because we're going to talk about some things that used to be prevalent in the wearz and the demo scene community. So I put up the rocket.info just to talk about it. But let's first start with exploring our history. So in the history lesson, in the beginning, there was Bell Laboratories. And it was good. And then, they kind of produced C, because you've got this problem where when you're writing Unix for the PDP-7, and then you want to port it to anything else, it becomes a problem. So when you get to the stage of worrying about the transition from mini to microcomputing, you start this ongoing process to build Unix. And then, a few years later, folks have this brilliant idea to start building new versions of the interior applications. And then when this keeps getting taken even further, it turns into BSDI. And, I'm no big fan of BSDI. I spent enough time adminning BSDI boxes, but, it becomes the genesis for SunOS. And then you get to the point of deregulation. And in 1987, Solaris becomes one of the mainstream commercially available predominant Unix distros. And then the same year you get Minix, and then building on Minix we get to the point of Linux. And we go, as this time period goes on, from having the Unix wars, not really Unix wars anymore, to the distro wars. We're going to put a pause there. We'll come back to it. So let's look at our present situation. I'm sure that a lot of you touch Ruby code.
Thank you. Thank you very much. You're going to love where this goes.
Ruby is an abstraction. Yes, it's a programming language, but in reality it's an abstraction. When you take something like Rails, you've got a router, you've got this data abstraction model, or you've got a mechanism for data abstraction, which is your model. You've got a mechanism for display abstraction, which is your view. And you've got this mechanism for execution abstraction, which is your controller. But it doesn't just stop at Rails. You also have things like bundler and like rack. And all of these things are done with the ostensible argument of making things become simple. But is simplicity a measure of success? Let's explore this a bit further. So in case study 1, moving away from Ruby for a minute, imagine that you have some piece of software that does a lot of useful things for you. Well, again, you're going to be stoked on this. So, you have a problem with this. You have this idea where you put it in a manifest and you expect to get an artifact back. And then it breaks. So why did it break? Blame DNS. It's always DNS, right? And then step 2, you see the pattern of where we're going here. Only it's not gnomes. So who here is a developer? Okay, so you know what to do. You blame the sysadmin. And who here is a sysadmin? Okay, well you know what to do. You blame the developer. And that's how this works. But you notice that with that model, there is no profit. The sock gnomes aren't winning here. What happens is that you started using a black box. And if we learn something from Frank Herbert, what's in the box?
Pain.
black boxes are the antithesis of open source. Like, even if your black box itself is open source, you aren't working with the community directly to really help folks understand how the black box works. You're only training people to be operators, not higher order or lower level users. To look at a different example. So there's this awesome piece of open source software called Shout. I highly recommend people look at it. It's, shoutirc.com. The idea of Shout is that it's a bouncer that runs in a web browser, or runs on your server, and you connect to it via a web browser, and it's written in Node.js. So we're going to analyze Shout as it's distributed as a container. So this is their Docker file. Pretty simple. Like, it's hard to get too much more simple than that. Like, it's start with a sensible base of Node. I mean, they're running Node, so like obviously you start with the namespace of like what makes the most sense there. And you install the application again. Like, when we look at this, they say all you have to do is npm-g install Shout, and you're running. And it's true. So you run that, and then you expose the port that Node is going to execute it on, and you get the command. But when you want to get a little bit more advanced, when you want to dig into it, you start on a different base. And then you have to start putting the software that you intend to use on top of it. And then you start refining the process by adding in additional things. And you start figuring out more of the tricks, and you start picking up speed. And what do you get from this? Like, you get an output artifact. And it's a highly reproducible mechanism for doing this. And just like Act 1, we'll come back to this. So now we go back to 1999, when everyone was focused on Y2K. Like, I promised a discussion of wearz here, so we have to loop it in somehow. So let's start with Scene Disc Magazine. It's a really awesome demo zine magazine from back in the day. And you'll notice up here, let me reach down and grab this. So, that's not the right tip. That's a little too much oons for this party. So we're looking in 1999. We've got this idea that people, as a renaissance, they need to learn to code again. People forgot to code? Well, specifically in this context, they're talking about demos. And just to make sure that everyone's clear, like what a demo is and what the demo scene is, a demo is this non-interactive program that's just designed to show off how good of a programmer you are. And I've got a couple examples here. So like, this right here is a demo that was created in 2003. Like, there's a whole bunch of like crazy audio and stuff that comes out of it. And I'll play nice and put their info file up here and give shout-outs and credits. Another example of this is that the whole point of a demo is that you have the ability to write a piece of code that utilizes the hardware in an optimal manner and generates something that's interesting for the user. Now, yes, that's interesting to watch, but both of those are 64 kilobyte executables. I want you to think about that. They did that in the amount of code size specified as a requirement for COM in the DOS era. How many of you think that you could write anything nearly that interesting in 64 kilobytes of code? I know that I cannot. But the idea of like what this guy is talking about in learning to code again is step one, optimize your code. And it's funny with the comment, are you nuts? We have Pentium 2s. We don't need to optimize our code. And also like make the code run on more than your PC. And that's one of the things that is a major goal of containers. So it's awesome that we're finding ways of doing this. So why does a zine article from 1999 matter? The idea is that often programming is seen as an exercise of expertise. And if that's the way you feel about it, go write brainfuck. That is an actual program that compiles into Hello World, by the way. Like, you can copy and paste that and run it through brainfuck, and you will get a working thing. But my my proposition here is that it's not the programming which is impressive, though it can be. I mean, that's the whole idea of like beautiful code and all of that. But it's the output and the functionality, which is far more interesting. So we got to hold the phone a bit. Like, we're at Container Days. I've barely even talked about containers, and I admit that. Fortunately, we've still got a little bit of time. So I bring our third act to a close. And what we're going to do is we're going to go back and start popping things back off of the stack. So in the case of shout, we go back and we've got this, and we're going to start optimizing it more and more and get to the point where we're building out the things the way that we want them. But we hit a point where our optimizations begin to get harder and harder to follow. Like, if you want to truly understand this, there's greater and greater leaps of logic that you need to do to track down what's happening. So this is the Docker file for Node itself. And you notice that even we're getting to the point where, like, you know, even the froms here just keep going deeper and deeper. Yeah, you're not running on Ubuntu, though you may have thought you were just because you had apt available. You're actually running on a user space called buildpackdeps, and then their flavor of Jessie. And then you get into doing all of the individual, like, curls and everything in your actual container. Now, the interesting thing here about this to me is that when I'm looking through this, like, you know, they're just doing direct curls down. Fortunately, they are verifying that the data wasn't modified in stream. But how many folks building containers are actually doing that? They're at the point where it's curl pipe bash, which is a security vulnerability, any way you look at it. But when we compare this to what the actual requirements of shout are, let's look at the source. Total of 556K worth of source. It's not our 64K executable, but, you know, we have 64K or 556K worth of source to work with. What does this get you? Now, I picked on shout because I like the software so much. But this screenshot is directly from their documentation. That 556K of source turns into an 833 megabyte executable. And today, that is the state of the art. When you look at the containers that people are building, they start with from Ubuntu, and they quickly get to a gigabyte worth of dependencies. And so yes, it is self-contained. But it's self-contained in such a way where folks are not necessarily processing all of the things that they're doing. And I think that there is some latitude for us to become better here. So let's start recognizing what's been happening here. So with case study number 3, we're going to talk about, like, what it is you're actually doing with containers. Are you utilizing frame buffers? Administering users? Are you logging in? I hope you're not logging in. I mean, that's for folks who were here earlier for the presentation, that's where I was, like, railing against SSHD inside of a container. Which is, I want to be clear, it's not that there's a problem with running SSHD inside of a container. It's that if your container is done correctly, ideally you're providing telemetry back if there's an issue. And you've already spec'd out the hardware, so you know that the hardware itself has been optimized, or that you've done your sysctl.conf in such a way where things are optimized. But it's this gray area where folks just kind of YOLO it into production, and then when there's a problem, they don't know how to troubleshoot it, so they just start the process of I SSH in and I throw the kitchen sink at it. And all of those things are the purview of general purpose computing. So I'm going to take an aside here for a second. And this is where, feel free to plug your ears and everything. So this is where I talk about my product, just for a moment. So CoreOS is not a general purpose Linux distro. It solves a very specific piece of a containerized workload. And I feel fortunate in that, like, we solve a specific piece, and, like, Gabriel over there has taken this and built an awesome product on top of that, which builds even further. And all of these things together are individual pieces of a larger puzzle. But what is the point? The point is that while you do need some abstraction in your work, we're much too apt to take the simple road. And if this is, in the case of general purpose computing, or if what you're looking for is general purpose computing, a general purpose distro is fantastic. And I would be the first to say, CoreOS is not what you are looking for. Now that's going to be different from a lot of companies, and I'm sure that, my colleague here is cringing as I say, CoreOS is not the thing you're looking for if you are trying to do general purpose computing. But the reality of it is that from a community perspective, you're never going to be happy. And it's going to be a constant battle. And no one should be having to battle this. So when we think about what these abstractions are doing, I'm loath to put it in writing, but what are the abstractions doing? Are they making us lazy? Are they making us unknowledgeable? I'm not entirely certain. But at the very least, we need to recognize where these things are taking us, where these ideas and where these abstractions are taking us. So, the takeaway at this short point is that this isn't about how good you are. This isn't about how good of a demo you can write. It's not about how efficient you are. But this is about abstractions. And it's about understanding. In a strange way, it's about mentorship. Because all of this is about community. And now that we've got this level set of talking about making sure that the technology is understandable, that you do hard things sometimes so that you understand why you don't take the simple path, I'm going to get into talking about a little something else. So one of the things that we are doing at CoreOS is we are working on a project called AppC. So AppC is a specification for containers. That's it. It's not a runtime. It doesn't do anything for you. It's just this specification that gives you a consistent mechanism for the design and the execution of an application in a container. So AppC is not Rocket. Rocket was mentioned earlier. Rocket is a container execution engine in the same way that Docker is a container execution engine, and LXC is an execution engine, and systemd nspawn is an execution engine. They all do similar sorts of things. And that's one of the key things to talk about here, is that AppC does not do those things. The idea of AppC is that we are open. And when we say open, it's an independent organization. And we've had collaboration from GitHub, from Red Hat and Google and Pivotal and Mesos and Cloud Foundry and Twitter and a bunch of others. And that it's going to be simple to actually implement, and simple from the perspective of being efficient, but simple to understand as well. And that we want it to be optimizable as well. Now, when I say optimizable, there are certain things like using content addressable caching, which is basically that you are able to hash your content and reference the content by the hash, so that if I attempt to reference this data on disk, I know it's going to validate to what I expect it to, and I know it hasn't been modified. Which leads into the idea of it being secure by default. Like, we want to have cryptographic addressing of the images, and image signing, and encryption of the images if you decide that that's the way that you want to run your workload. Personally, the idea that you might have a container with some configuration, because it's a one-off sort of thing, that might have secrets in it, means that you want encryption for that. You want to guarantee that the data cannot be compromised easily. And that also that these pieces come together in a composable fashion, meaning that they can integrate with existing things easily. That they're going to be architecture agnostic and OS agnostic. One of the first things that happened when we announced AppC and actually then released Rocket as an implementation of it was 2 weeks after that, a community user from Poland contacted us and said, hey, please take a look at this. I wrote an implementation of an execution engine in AppC that is built on top of FreeBSD and uses ZFS and jails. What? Like, we put together the spec in such a way that there was like an operating system and like kind of a class field there. But those were just kind of no-ops that we put Linux in for both of them and never thought anything more about it. So it shows that the idea of trying to guarantee that this is a community-based effort that anyone truly can contribute to pays dividends. I would have never thought to be in a situation where I create some minimal container and then I hand this across to a completely different platform and that it will be able to run that container using the native mechanisms for the components that the specification designs. Like, you know, that the executor for Linux will be compatible with the executor on a FreeBSD machine, or that the isolator on Linux will be compatible with a process isolation mechanism on a different platform. Finally, that it's standard, meaning that it can be built with easily known and understood tools. Again, going back to a degree of understanding. We felt that this should be something that you don't need to take a distributed systems course to understand. Like, you should be able to do this with all of your well-known tools that you're used to using today. But at the same time, that it should be extensible, so that if you decide that you want to start using BitTorrent as a transmission mechanism for your containers, that you can. Because, so think about this a second. All of you are designing applications. You're building businesses around them. And you get to the point of running a 5-node cluster. And you get excited because now you've got 1,000 customers signed up and you're able to support them on that. And then you grow to the point of a 100-node cluster and then to 1,000. And it is my genuine hope that every one of you can build a business that is sustainable in the size of the next Apple or the next Facebook. But if you do that, you're going to be running tens or hundreds of thousands of machines. And all of a sudden, HTTP is not the most efficient mechanism for distributing changes. Like, just because you don't do that today doesn't mean that this technology that we're using for wearz and to grab our demos and everything else that we're looking at isn't valid for other purposes. And it, again, comes back to having this degree of understanding about the way that the pieces can be put together is going to lead to vastly more innovation in the field than any of us necessarily intended in initially thinking about this. So we've got the idea that the AppC principles themselves are that it's open, that it's simple but efficient, that it's secure and composable, and is based on standards that folks actually understand. Well, the second side of this becomes the components. So for the image format, it's something, and this is an application container image, it's a tarball. That's it. It's a tarball, and there's a manifest that just tells how to run it. The manifest is kind of like your Docker file. But I'm going to be giving a presentation tomorrow on actually building root images, root minimal container images. As I figured it would be a pretty jerk move to sit and go, look at these guys creating their 833 meg container. Yeah, they're not doing it right. So, I mean, I have a working implementation of that I use for my own stuff that's 5% of the size. And I want to make sure that every single person here who wants to do that walks away with the knowledge and the support that they can do it, and that they can share that with others, and that this isn't some dark witchery, it isn't some embargoed information that nobody knows how to do. I want to make sure that everybody who is so inclined feels empowered to actually build something without relying on the packaging of Ubuntu. The next thing here is that we have an image discovery mechanism. So what that means is it just maps an app name to an actual artifact. the idea is to be able to take some simple address like example.com, HTTP server.aci, or all the way out to using like meta tags and being extensible in that fashion. For anybody who writes Go code, you'll find that that's actually how some of the namespacing of packages is actually leveraged. They use simple meta tags and static HTML pages distributed over HTTP to like make sure that things can be scaled in an efficient manner. We also have the idea of an executor. This is just the thing that sets up the actual execution environment. So this is the runtime environment. This is how an AppC image actually is laid out on disk and executed. And then it uses those isolators to kind of enforce resource constraints and provides a basic layer 3 which gives the container the mechanism for actually talking. And it's why we specify very generic things like this, because as was evinced by the folks over working on Weave, like they very quickly saw, no, real organizations with real deployments have real networking needs that aren't just NAT. Because, we are, tidbit for folks who have not traveled that much outside of the US, the United States owns 70% of the IPv4 space. The rest of the world is sharing that 30%, which is why they're the ones driving IPv6 adoption. You talk to US companies and they go, ah. And June 6th rolls around every year and there's a little pat on the head and Comcast does their big hullabaloo, like, look, we provide IPv6 to the home. And then all of the American companies, the American startups go, yeah, but I mean, that's hard. Yeah, there's no NAT. How do I do a firewall? And this, you'll notice, it just keeps coming back to folks don't do things because there's a perception that they're hard. And I want to make sure that you realize that together we can actually have a deep understanding of these technologies. And that there's no barrier besides the urge and the want to know them. So, by extending this in such a way where you just have simple requirements like that, you're not tied to opinionated mechanisms for doing that. Now that, again, I work for an opinionated Linux distro. I think that having strong opinions is great, but I also don't feel that they should be a mandate on the user. They should be a guidance where, like, you can rage against that machine if you want to, but it's not necessarily going to be easy. And with a specification, you should have additional options. The last piece of what's required by AppC is just a metadata service. So this is the idea that you have some external source of truth that I can verify with before talking to a container. So like, let's say that I was using, or that I was authenticating like a database container to a web container, or vice versa. By having a metadata service, I can now talk to that and ask for identity of the container, and then do something like an HMAC verification against another component, so that I can trust that I am actually talking to the pieces that I expect to be talking to, and can fail it in a consistent manner if, for some reason, things aren't going exactly the way that I expect them to. So, I have just blown through 125 slides in less than 30 minutes. I was expecting that to take about an hour. At this point, I am going to gladly, kick things back to Ernest, and hopefully he has his bits prepped for this. And I thank you much for your time. And by all means, come get involved tomorrow and show us and ask questions about what you want to learn, what you want to know about containers. Thanks.